on here. All right. Shh. So section 5.1 was acids and bases. Section 5.2, salts, which are not what you think. Salts, not just for fries. In science, a salt is a very specific chemical definition. They are compounds that are produced in three ways. The first way is if you mix an acid and a base. One of the outcomes will be a salt. The second way, and this one's going to seem a little bit more obscure, Alex, is if you mix what's called a carbonate with an acid. What's a carbonate? If you look on your pink sheet on the back on the polyatomic ions, there's a carbonate ion. So if you have a chemical that has a carbonate ion and you mix it, that's why I was staring at you. If you mix it with an acid, one of the outcomes will be a salt. And the third way that you can get a salt is to expose metal to an acid. What's the common compound throughout all three of these acids? How can you recognize an acid? Starts with an H, but keep an eye out for the sneeze, chaku. Okay, so it's hopefully kind of Ryland tying together with what we've already done. Salts are used all over the place. Turns out we use these in batteries. Not table salt, obviously, but a different type of salt. Our cells need some salts to survive. Fertilizer. And that's just scratching the surface, etc., 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 etc. So the first type of reaction we're going to talk about, and this is going to be our phrase for a while, is what we call an acid-base neutralization. Now let's see if we can decode that word. What's the first word there, Dylan? Acid. Okay, so there's going to be a compound that starts with an H, or the weird chaku one. What's the second word there, Alex?
Base.
Base. So there's going to be a compound that ends in what? A hydroxide or an OH. Okay. Neutralization. Oh, acids and bases cancel each other out. What's a fancy word for cancel each other out? Neutralization. So these are called acid-base neutralization reactions. In fact, if you have an upset stomach, it's because you've got too much stomach acid. If you take a Tums, that's a base. There's a base in there to neutralize your stomach acid. So we said this. Acids release hydrogen ions, protons. Bases release OH negative ions. That's why a base has to have an OH in its chemical formula. It splits up when it's in water, and so those OH negatives are floating around in the water. When an acid and a base are mixed, they form a salt and these guys combine. I heard someone say it. Water. Can you see HOH is actually H2O in disguise? Then to get the salt, what you usually do, Jess, is you just boil it. The water boils away, and you're left with, here's your fancy word, a precipitate on the bottom, some kind of residue on the bottom, something powdery of your whatever your beaker or your test tube. There's the salt. So here is an acid-base neutralization, Jasmine, reaction. Here's how I can tell. Jasmine, look at the first chemical. What does it start with right here? Acid. In fact, this is hydrochloric acid. This is your stomach. Look at the second chemical, Julie. What does it end with? The whole thing. OH, it's a base, okay? And I'm teaching you, this is how you can recognize, hey, this is an acid-base reaction. Acid, base. And Julia, let me think. You know what? I think, Julia, I'm going to be nice. I don't think I'm ever going to give it to you base plus acid. I'm going to decide right now, if I give it to you, the acid will show up first and then the base. I'm not going to try and trick you. Now, look at this chemical reaction. This metal right here, see it, combines with this non-metal. There's where you get NaCl. And this hydrogen and these OH combines to become, H2O. Table salt and water. There is an acid-base skeleton equation, but what did I ask in brackets? What did I ask in not in brackets. What did I ask right here in the arrow? We need to practice balancing, and I know some of us are having trouble, so I'm going to go slow. If you've wrapped your brain around balancing, balance this equation. Those of you that have not, let's do our careful list. Julia, I'm going to pick on you and love my joy. Try this again. How many H's are there on the left-hand side? Nice. How many Cl's on the left-hand side? How many Nas are there on the left-hand side? How many O's are there on the left-hand side? One. Count on the right. You know what? I'm looking. I think it's already balanced, is it not? This one is. And you may find once you list the first bunch, it's balanced. You don't need to go any further. In fact, some of you may have seen that already. That's also why this is a very, very easy chemical reaction. Table salt. Next one. H2SO4. Oh, what's that start with? Acid. This is sulfuric or I don't know. It's an acid. Plus AlOH3. Oh, what's that end with? Hydroxide base. This is an acid-base neutralization reaction. And Tyra, what's going to happen when you mix these together is this aluminum is going to combine, don't circle that, I'm going to really gum this up, with that SO4, who's got their pink periodic table? You're going to need your pink periodic table out. Is that sulfide, sulfate, sulfite? Sulfate, okay. It's going to form aluminum sulfate and water. Is this balanced? I can already tell you no, because how many aluminums do I have on the left-hand side? How many here? Okay. Hey, let's try balancing this without listing everything. So you ready? Julia, I'm going to pick on you again, my love. It's all fun. Julia, how many ALs, how many aluminums are there on the left? How many here? So for starting, if I'm going to guess, I would say I'll need 2 of those. Is that okay? Now, I better count my... You know what? I'm not sure I can do this in my head. Well, let's see. Taylor, you ready? How many H's right here? 2. How many right here without the 2 in front? 3, but with the 2 in front, there's what? Okay, you know what? I think I'm going to have to write something down. So right now, I have a total of 6 H's and 2 H's. How many H's? 8? How many H's do I have on the right? How many do I need? How can I fix that? Okay, so try putting a 4 there. That's going to give me that. Well, let's save the O's for last. Let's do the SO4. How many SO4? Oh, you know what? I probably should have done the SO4s before the 8s, before the H's. I should have waited. Because how many SO4s do I have on the right-hand side? How many of these do I have? 3 SO4s, right? How many SO4s do I have on the left-hand side? You're right. 1. How many do I need? You know what? Maybe before I start mucking around with all this stuff, maybe what I should have done is I should have said, let's see if I put a 3 there, because maybe that'll take care of it. So the rule when you're doing an acid-base reaction, save the O's and the H's for last. If you're lucky, they'll take care of themselves. Let's see. That gives me my A's balanced, and that gives me my SO4s. What was sulfate? Is that what you guys said it was? My sulfates are balanced. Okay. How many H's do I have here? 6 plus 6 more? 12. How many H's do I have on the right? Right now? 2. I want 12. Now let's see if the O's work. I think they do. Ready, Cam? How many O's here? There's originally, oh no, never mind, I'm not going to count that. I treated that as one funky molecule of SO4, so don't count that O twice. Let's scooch. Oh, here's some O's. How many? 3 here, but then what's in front? Making a total of? I'm not going to count this O. That's inside SO4. I'm treating that as one funky molecule. How many O's here? We're balanced. Whew. We're balanced. By the way, in English, we would say acid plus base gives, well, you know what? A salt plus water. That's a standard neutralization reaction. Hey, Courtney, this base is under assault. Yeah.
How come if you're like boiling water and you put salt in the water, how
Yeah.
come it makes it boil faster?
I don't know if it makes it boil faster as much as it reacts with the water, because compared to the water, it's cold. I suspect there's some type of more complicated thing going on there, similar to when you drop water onto a red hot plate. The water reacts very fast because the water compared to the plate is cold. I suspect it's more something along those lines, but I will ponder and see if I can give you a better explanation. But now I got to get back here, but that's a good question. Part of your homework is going to be from section 5.2, page 91, number 1. Oh, you know what? I think we're going to do them right now. Let me just double check here. Is this page 91? Why do I have page 91? I think I meant to delete that. I don't think page 91 is the right page. Hang on here. Oh, I know what I mean. Hang on. Pause. Hey. So take a look at this. This is section 5.2 homework. And what I'd like you to do is literally take 60 seconds and just do number 1. So how about we use the letter A for acid, B for base, and what would be a good letter to use for salt? S. In number 1, next to it, state whether it's an acid or base or a salt. And here's your hint. How do you know it's an acid? Starts with an H. Don't forget Chaku. I see it sitting there. How do you know it's a base? Ends in OH. Otherwise, I guess it's a salt. Now, a salt is going to be even more specific. It's going to be a metal plus a non-metal. You're going to notice that. So I'm going to give you 60 seconds. Try this, and we're going to go over the answers real quick. So, Sage, are you okay with how almost at a glance we can tell the difference between an acid, a base, and a salt? Because if you can't recognize that, you can't start to really do much more. Okay? Practice problems. So you ready? Here are some acid-base reactions. I actually took these from your textbook. We're going to do them together. These are neutralization reactions. There are going to be some on your Chapter 5 test. So focus. Ready? A lot of the people that are sitting next to each other won't be sitting next to each other next time. Number 1, I filled in for you. Now look, notice how they combine. The metal that's attached to the base combines with the non-metal that's attached to the acid. And then the H, the hydrogen, and the hydroxide become water. Then I check if it's balanced. I also have to crisscross properly. So there's a lot to put together here. So you ready? Is number 1 balanced? I think it is. I think so. Okay. Number 2. Well, I'm going to end up with water. Let's fill that in, plus H2O. And what other two are going to combine? The magnesium and what's CO3? It's from the back of the pink sheet. It's carbonate or carbonide or what is it? What's CO3? Carbonate. Those two are going to combine, except I can't just write MgCO3 because I might have crisscrossed wrong. What's the charge on magnesium? What's its ion charge? Sorry? 2 plus? What's the ion charge on CO3? This is all from your pink sheet. Is it also 2 minus? Oh! These ones do crisscross in a lovely one-to-one relationship, so I don't need to add any subscripts down here. Then I need to check if they're balanced. How many CO3s? 1, 1. How many magnesiums? 1, 1. How many hydrogens? 1, 2, 3, 4. Dope. How many hydrogens here? 2. So right now I have 4 H's. Right now I have 2. How can I fix that? Oh, how many oxygens do I have here now? 2. How many oxygens do I have sitting in here? 2. So I have 1, 2, 3, 4 hydrogens. Check. And I'm not going to look at the oxygen here. I'm treating that as one funky molecule. But I am breaking up the OH. And by the way, that's one of the questions that I gave you on your last chapter test, which is why we had to break up that OH that was in brackets. And I know I haven't gone over the chapter test yet, but I will be in a couple of days with you guys. I think we're balanced. Okay. Example 3. Here's my Chiku acid. Here's my base. How are they going to combine? This one's trickier, so look up. This hydrogen right here will combine with those. I'm going to get H2O. When I yank off a hydrogen from Chiku, I'm left with CH3COO, no H. That's on your pink sheet, isn't it? I hope. Dylan, what is it? It's acetate. What's its charge? You're right. It is. Yep. Negative? And what's it going to bond with? It's going to bond with CS. What's the charge on CS? Oh, positive. Kyle, will this crisscross okay? Oh, this is good. So it's going to be CS, CH3COO. You know what? That's such an ugly molecule. I'll put it in brackets just to remind myself that that's one weird, funky polyatomic ion. Now we balance. How many CS's on the left-hand side? 1. How many CS's on the right-hand side? 1. How many CH3COs on the left-hand side? 1 right there. Right? How many acetates, can I call it that? How many acetates on the right? 1. How many H's on the left? 1 there, 1 there, 2. 2. How many O's? 1. What? Holy smokes, it's balanced. Holy smokes, it's balanced. Okay. I'm going to pause. See if you can try doing 4 and 5 on your own. You're going to have to, first of all, realize that the Na and the PO4 will combine. You might need to crisscross to combine them properly. I'm going to freeze the screen. I'll do them up here. Take about 60 seconds or so, and let's see if we get the same thing. 4 and 5. Try them right now, please. You can work with your partner next to you and talk about it if you want. That's okay. So, first thing that I did was I said, okay, one of the products is going to be water. I like writing that because, Jasmine, my question's no longer blank. I feel better. I've written something down. I'm more relaxed. Go figure. Then I said, this and this are going to combine. So over in the margin, I said, okay, I know sodium from my periodic table is a plus. And what is PO4 called? Phosphate, phosphate. It's 3 negative. So I did my crisscross. And Alex, I said, okay, it's going to be Na, 3 of them, PO4, 1 of them. Now you can put it in brackets if you want to, but traditionally if there's just 1 of them, the brackets are not mandatory. Then I said, okay, let's balance. Sage, is that okay so far?
Yeah.
What's the obvious one that you can see not balanced? Sage, how many NAs do I have here? How many here? So the first thing I said was, well, why don't I do that? You okay with that? NAs are balanced. PO4s, how many do I have here? Well, what number is in front right here? It's invisible. 1. What number is down right here beneath the 4? It's invisible. 1. So I got 1 PO4. How many PO4s do I have here? No. Right? And I'm glad you made that. That's the mistake a lot of kids are making. Okay, Sage? The 4 is on the O, but how many PO4s do I have? 1 PO4. So the PO4s are balanced. Now let's check the hydrogens. Ready, Sage? How many H's right there? 3. How many H's in here? And then what's in front? So how many H's grand total here? How many were back here? Okay, so how many in this one? 3. How many in this one? How many H's grand total on the left?
4, 5, 6.
Okay, not allowed to guess. So ready, Sage? How many H's did you say were here? Yeah, it's okay. Do you understand why, right? You said there was 3 here. There was 3 here. Let me erase that because that looks like weird, funky subscripts. So how many H's on the left? 6. How many do I need on the right? How many H's on the left? 6. How many do I need on the right? Same answer. 6. How many do I have right here? 2. How can I turn this into 6? You okay with that so far? Now let's count the oxygens. Now again, don't count this O. We treated this as one funky molecule. I'm just going to count this O. What's in front here, Sage?
3,
How many O's grand total here? 3. How many O's over here?
4,
3 were balanced. Okay? Yeah.
Why do you treat that as one molecule but not the other?
Because it's on the back of my pink sheet, it's a polyatomic molecule. It's a polyatomic ion, so I'm going to treat it as one funky. This is why I keep saying, get out the pink sheet. If it's on the back there, treat it like one funky molecule or one funky ion. Now this one is as well, but I know this is going to split up and join because I know I got to get that water. That's why I'm always going to, in an acid-base, you asked a great question. In an acid-base neutralization reaction, I'm going to split up the OH because it's got to combine with the H from the acid to give me water. Is that okay? Great question. Great question. 5. HNO3 plus COH2. Say what? HNO3 plus CaOH2. Okay. Here's my acid. Here's my base. And Matt, this OH is going to split up, but this NO3 I'm going to treat like one. In fact, if you want to, you can always go like that just to remind yourself to treat it like one funky molecule. I don't want to take marks off. It's technically not good chem manners because you're doing brackets when you don't need to, but I have no problem with that. So what are the products? I know one of them is going to be water. And then, Rachel, the other one is going to be calcium. I'll change colors. Calcium is going to combine with NO3. What's the charge on NO3? Negative. NO3, which is called nitrate, is negative. What's the charge on calcium? I don't think it's a negative or plus. 2 plus? So when I crisscross, I'm going to get 1 Ca, but how many NO3s to make this work? It's going to be an NO3 in brackets with a 2 there. As soon as I do that, Rylan, can you see there's one staring out at me as being unbalanced, this thing? Because how many NO3s, how many nitrates do I have on the right hand? Don't erase it, Mr. Dueck. How many nitrates do I have on the right-hand side? How many on the left? So the first thing I'm going to try is that. We have just balanced the nitrates. How many calciums on the left? How many calciums on the right? Okay, that's good. Now let's check the hydrogens. And have you spotted the pattern, Tyra? I save oxygens for last because I'm kind of hoping oxygens will take care of themselves. I save hydrogens for second last because they're going to need some balancing. So, Rylan, let's see. I got 2 hydrogens here. See it? And how many hydrogens here? Careful. Careful. 2. How many hydrogens on the left grand total? How many do I need on the right? How can I do that? Times a 2, but yeah, put a 2 there. Now, if we're lucky, the oxygens have taken care of themselves. Let's see. How many O's on the right? 2. How many O's on the left? 2. We're good. Joseph, is that okay? It's going to be some of these acid-base neutralization reactions on your test. And this is, Andrea, one step further because now I'm actually asking you to predict the product. But I'm telling you one of them is always going to be H2O, water. Keep going. Keep going. Oxides. What do you think an oxide contains? Pardon me? Oxygen. Compounds containing a metal ion and an oxygen ion. These don't produce acids. These produce basic solutions. Say what? So you ready? Is this an acid? Does it start with hydrogen? Nope. So this is a metal, sodium, and an oxygen. This is a metal oxide. Combine it with water, and what's going to happen is we're going to get NaOH. A base. Now, how the heck did I figure that out? You guys wrote that down. I'm going to erase it. Here's what I said. I know I'm going to get a base. What makes a base a base? What does a base end in? And that sodium's got to go somewhere. What's the charge on sodium? Plus, what's the charge on OH from your polyatomic ions on the back? Oh, when I crisscross, this will work quite nicely, Joseph. I'll get NaO, sodium hydroxide. Now we balance. How many sodiums on the left-hand side? 2. Maybe I need 2 here. How many oxygens on the left? 1, 2. How many oxygens here? 2. How many hydrogens on the left? 2. 2 hydrogens here. We're balanced. One more and we're going to pause. Well, maybe we'll get to non-metal oxides and then pause. CaO plus H2O. Now, what's H2O? Water. Ca, metal, calcium. O, oxide. So first thing we need to figure out is how they're going to combine. They're going to combine into calcium and a hydroxide. What's the charge on the hydroxide? Negative. What's the charge on calcium? I can't remember. 2 plus? When we crisscross, we're going to get calcium, OH, and in brackets, what number will I have down here outside of the brackets? 2. Now we balance. How many calciums on the left? 1. How many calciums on the right? 1. How many O's on the left? 2. How many O's on the right? 2. How many H's? Oh, you know what? It is balanced. I'm going to finish this, and we're going to press pause for a while, and I'm going to give you some homework to practice. Then we have what we call non-metal oxides. If it has the word oxide in it, what element do you think is in it? Okay? This is a compound which contains a non-metal and at least one oxygen. These produce acidic solutions. SO2, sulfur dioxide, because it's covalent, plus H2O, water, or dihydrogen monoxide, because it's covalent, produce, well, it's going to produce an acid. The fact that it's going to produce an acid tells you it's going to start with what? H. And in fact, I'm going to tell you it's going to produce H2SO3, sulfurous acid. Can you take a look at the sheet that I gave you called Section 5.2 Homework? This puppy right here. So your first bit of homework to try and get done in class is the take-home quiz. But you can certainly, if you haven't done number 1, you can do number 1. You can do all of those. Now, you may need to look some of this up in the textbook to see where all these acids and bases are, but they are in your textbook. So what acid is present in vinegar? What's the chemical name for table salt? What acid is used in automobile batteries? If you look, this is all from pages 234 to 239. I haven't gone into all the detail. Turn the page. In theory, you should be able to do number 1. I'm going to spend some more time on this on Wednesday, but we've done some acid-base neutralization reactions, except I can't do them in one line. Maybe you can. If you need to do the work for balancing on a separate piece of paper, go ahead. And number 2, now we're going from the name to the balance. This is much tougher. Mr. Dueck, what's sulfuric acid on your pink sheet? What's acetic acid on your pink sheet? What's phosphoric acid? I sure hope it's on your pink sheet. Oh, phosphoric acid is not on your pink sheet, but I think it's in the textbook. Nitric acid is on your pink sheet. Sulfuric acid is on your pink sheet. Hydrochloric acid is on your pink sheet. So this one you might need to look up from the textbook. You capable of doing that? And then you can certainly do number 8 And number 9, you may be able to do 1 through 7. I just haven't quite got through all the details yet. Okay? So quiz first, then those, and I'm going to shut up and continue this on Wednesday.